Hello, this is Zen or Mustafa. So today we are going to discuss how the variables are actually saved inside the random access memory, because this is one of the most important topics that I learned while I was in my university times, and I was basically going through this object-oriented programming and the related stuff and studying about the embedded systems and all that kind of stuff. So I was a bit interested in understanding the concept behind. Okay, so this is what a RAM actually is. A RAM is a random access memory, which is a temporary memory, and and whenever whenever you lose your power or something, when you turn off the switch of your random access memory, the memory is gone. So for a memory to stay, you need to provide it power continuously. But anyways, when we are writing a program, the RAM is loaded up with the variables. And the important part, how the variables are getting loaded into the random access memory, is quite important. So let's take an example of integer values. So let me declare an integer value here. Let's say int, and maybe int value 1, let's say, and value 1 can be given a value of maybe 5, let's say, you know and when you declare this variable, for example, this value number 1, a value of 5. Now what we know, that each and every single thing that you declare to a variable, and since you have declared this data type here as int, it basically means that, okay, every single data type will have certain bytes, will consume certain bytes inside the random access memory. So for example, a normal character, like any character, actually you pick up any character, you can test it out in your notepad file as well. But if you pick one character, usually one character takes 1 byte. So if let's say my name is Zen, for example, Zain, so Z is going to take 1 byte, A is going to take 1 byte, I and N are going to take 1 bytes. So a total of 4 bytes. Now what integer takes is 4 bytes. So one, if let's say what I have declared here as value number 1 will take 4 bytes inside the random access memory. Now let's understand what the random access memory actually is. So, and all the addresses and everything, which is not here, which is not quite important in that, but it's quite really important when you are trying to figure out a proper solution to a problem when you have a lot of data. So let's go to a simple spreadsheet, and I have basically these two columns here. So first column is the address and the second column is the value. So all the addresses are written here, but just notice the trend here. 100, 104, 108. These are just 4 bytes. 100 is just a base value that I selected, but I'm adding 4 bytes, per cell. So indicating that this cell is going to take 4 bytes, it's going to consume 4 bytes. So I'm all the 4 bytes, after 100, so 100, 100, 101, 102, 103 will be consumed by the integer value. The next integer value will reside here at 104, and then so 108, and then in 112, and so on and so forth. It will continue. But processor is smart enough because we have designed it that way. So whenever and the RAM is not infinite, it's a finite value. So we don't know exactly which addresses are free. So what process, and we don't care really where the variable is stored even. So what processor does, whenever we declare a variable, let's say what we have done in Dart, for example, value number 1, what processor will do, it will pick that 5 as a value number 1, and it is going to place in any of the location which is free, which is a free slot. So for example, let's highlight all of these slots, maybe with a color, let's say red, you know fill color may be red, and let's say this particular slot is white. Red is indicating that these slots are not available, and some value is stored here. But this 104 slot actually is free to use. It's not filled. So what processor scans through the addresses, and wherever it finds, okay, so 104 is free, it's going to take value number 1 and it's going to place here, right? So the processor just scans through the memory, and tries to find the the location, or maybe the space at which value number 1 can be placed. That's all about it. So it's there's a scanning process, and it's trying to fit that particular variable in that particular address, in whatever address it finds. If it doesn't find any addresses, you're likely going to run out of memory, and this is usually what the error we see when we try to run a lot of programs, or maybe a lot of softwares. You might have seen that your RAM shoots up, your RAM is consumed, which essentially means that other programs are not the processor cannot save the other programs variables inside the RAM, which is not available. So let's say if this is filled, is if this field is also filled, you know, let's turn it red, then when you do value number 1 equals to 5, declare an integer, value number 1 equals to 5, the error that you're probably going to get, or most likely you're going to get, is out of memory, because you don't have enough memory here, you don't have enough resources which are left here. So value number 1 cannot be declared, it will not be declared, because the value is not stored. That's the important bottom line. So this is all about that. I wanted to really let you know that whenever you're declaring the variables, be really careful what exactly you're doing. So one common mistake that I have seen people doing is doing this. For example, declaring a string, you know, and maybe string of value number 1. Value number 1 can be declared as I don't know, 5, for example. So this is going to consume, and I'm going to write how many bytes will it consume. So it's going to consume 1 byte, because character consumes 1 byte. One character is going to consume 1 byte. So if the value here is 52, then it's going to consume 1 byte for 5 and 1 byte for 2. So it's going to consume 2 bytes of the memory, right? And when you do this, declare an integer value 2, and you're parsing this integer to, let's say, by using this function, parse value 1. So obviously the result that you're going to get is of 52 in integer, value 2. If I'm going to, oh yeah, the semicolon, when I'm going to run this thing, I'm going to get 52 right here, but this is an integer now, because we have parsed this particular string into integer. And when you do this thing, then you're going to consume 4 additional bytes. So right now, after this stage, you have basically consumed 6 bytes. So the problem here is that if you are able to declare an integer on top, then you can literally save these 2 bytes from existing in the first place, because after you exit the program, you have to clear the memory, which is quite a big task. So why not just declare integer directly? Why declare a string and then assign a value there, and then parsing that string and consuming 4 additional bytes? So this is one common problem that I usually see, and it's not going to affect anything, because usually our memories are 4 gigs, more than 4 gigs now. It's 16 gigs, so 32 gigs is far more than enough. These 2 bytes or 4 bytes doesn't even make a difference. But the important bottom line here is, when you are creating a very humongous program, or when you're creating a humongous software, let's assume a mobile application, for example, then these are not just 2 variables which are getting stored. There will be a ton of variables which are getting stored, and you have absolutely no idea how many. You cannot even count how many variables you're using in a certain file, in just one file. I'm just talking about one file. So when you combine all those things together, your app will become heavy on memory. And when something becomes heavy on memory, it's going to consume of course the memory. It's not going to let other programs run when your app is running, which is obviously not a very good user experience. But also it will mean that since your RAM is getting consumed, RAM requires constant power. And when RAM is getting consumed and it is being used by the processor, then it's going to consume a lot of power from the battery source. So that's not a very good user experience, because first of all, your RAM is getting consumed, the second, your battery is getting consumed. So overall the user experience is going down. So save the variables. That's the whole point that I'm trying to make here. Floats, for example, floats take 8 bytes. Some floats 8 bytes. long integers take 8 bytes. So be really careful what you're declaring here, because these declaration and the availability of the RAM plays a major role. So I hope you understood this memory mapping and the memory management and the RAM and how the variables are getting stored somewhat. In the next video, we are trying to see we are going to see how arrays play an important role and how we can store a series of data in the start thing, and then we are going to print out that stuff. But we're more importantly are going to see how the elements of that array are going to reside in this memory map that we have created in this Excel file. So that's about it, and thank you.